Hello everyone, myself Dr. Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's session on problems on volume integration. We know that the volume integral is the generalization of a triple integral in which we evaluate the integral of the given vector function with respect to three variables x, y, z. For example, if f bar is the given vector point function, the volume integral is denoted by volume integral f bar dv, which is the triple integral f bar dx dy dz. So, if we use the single integration along with this v, the volume, this is called volume integral, which means to evaluate triple integral. For example, if we use with s, which means to double integrate the given, so which comes under surface integral. And if we use this curve C, that is called the line integral. So here we are going to find the volume integral of the given. For example, if f bar is given in component form, simply we evaluate the triple integral of each and every component of that vector and then sum all the three. Now coming to the second problem, if f bar equal to 2x square minus 3z I bar minus 2xy j bar minus 4x k bar, then evaluate the first one del dot f bar and the second del cross f bar. So here del dot f bar. So first let us calculate these two. What is this del dot f bar? The divergence of the vector, which is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Similarly, what is del cross f bar? Curl f bar. I bar, j bar, k bar, the components of first vector dou by dou x, dou by dou y, dou by dou z, and the components of second vector f bar, f1, f2, f3. So finding this determinant that gives the cross product between del and f bar or curl f bar. So to find this, first we need to consider the given vector f bar in the form f1 I bar plus f2 j bar plus f3 k bar, component form. So here it is given in component form. This is f1, f2, f3, where f1 is 2x square minus 3z, the first component. f2 is the second component minus 2xy, and f3 is minus 4x. Now let us find all the partial derivatives. Dou f1 by dou x, dou f1 by dou y, dou f1 by dou z. Now first f1 with respect to x partially. Here 2x square term is there. So the derivative of x square is 2x. So we get 4x. And we treat 3z as constant. So this is 0. Now with respect to y, there is no y term, 0. With respect to z, we treat x as constant. So 0 minus 3. And similarly dou f2 by dou x minus 2y, dou f2 by dou y minus 2x, dou f2 by dou z, 0. In partial differentiation, we treat other independent variables as constant. Similarly, dou f3 by dou x minus 4, dou f3 by dou y, since there is no y term, it is completely constant. So 0, dou f3 by dou z, again the same. So these are the 9 partial derivatives, and we can use these values to find del dot f bar and del cross f bar. Now let us find del dot f bar. So dou f1 by dou x plus dou f1 by dou f2 by dou y plus dou f3 by dou z. So dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So 4x minus 2x is plus 0, which is 4x minus 2x plus 0, 2x. And del cross f bar, which is the determinant of this matrix. So I bar into dou f3 by dou y minus dou f3 by dou y minus dou f2 by dou z minus j bar into dou f3 by dou x minus dou f1 by dou z, dou f1 by dou z plus k bar into dou f2 by dou x, dou f2 by dou x minus dou f1 by dou y. So let us substitute all these values. That's why we have calculated these 9 partial derivatives. Now first f3 with respect to y, f2 with respect to z. f3 with respect to y is 0, f2 with respect to z is 0. So there is no x component. Minus j bar, f3 with respect to x, minus 4, f1 with respect to z, minus 3, plus k bar into f2 with respect to x, f2 with respect to x, minus 2y, f1 with respect to y, 0. Hence, there is no x component, so I bar term will not be there. Minus 4 plus 3, minus 1 into, so j bar minus 2y k bar. So, in the first problem, we need to evaluate the triple integral of this 2x. In the second problem, this vector j bar minus 2y k bar. Since the divergence is the dot product that gives a scalar and curl is the cross product which gives a vector. And now, to find for both problems, we need to find the limits. So once again, where v is bounded by x0, y0, z0 and 2x plus 2y plus z equal to 4. So we need to evaluate the triple integral corresponding to the given region. So therefore, v is bounded by x0, y0 and z0 and 2x plus 2y plus z, 2y plus z is equal to 4. So here, as I discussed in the last session, in evaluation of triple integral, we find one of the limits of one variable in terms of remaining two. For example, here z limits, let us calculate in terms of x and y. So therefore, z changes from 0 to 4 minus 2x minus 2y. This is some equation 1. Now, to find y limits, put z equal to 0 in 1. So 2x plus 2y equal to 4, x plus y equal to 2. So that implies y is 2 minus x. And therefore, y changes from 0 to 2 minus x. And this is equation 2. To find x limits as constants, put y equal to 0 in 2. So x equal to 2. That implies x changes from 0 to 2. So these are the limits of x, y and z. So coming to the first problem, volume integral del dot f bar dv means to evaluate x from 0 to 2, y from 0 to 2 minus x and z from 0 to 4 minus 2x minus 2y. And what is del dot f bar? 2x. Z first, then y, then x. 2 is constant. So x from 0 to 2, y from 0 to 2 minus x. Since we are integrating with respect to z, x, we treat x as constant. So we write x outside, then integral dz is z between the limits 0 to 4 minus 2x minus 2y. Now apply the limits, x from 0 to 2, y from 0 to 2 minus x into 4 minus 2x minus 2y, and the lower limit is 0. Now we need to integrate with respect to y. So 2 into x from 0 to 2, y from 0 to 2 minus x, 4x minus 2x square minus 2xy dy dx. Now with respect to y, we need to integrate. So The first one 4x constant, so integral dy is y, 4xy minus 2x square y minus 2x into y square by 2 from 0 to 2 minus x dx. So here these two gets cancelled, and then we need to simplify this. 4x into upper limit is 2 minus x minus 2x square into 2 minus x minus x into 2 minus x whole square dx. So this is 2, x equal to 0 to 2. So overall, let us simplify this first. 4 into 2, 8x minus 4x square minus 4x square plus 2x cube minus here a minus b whole square. So a square is 4, so minus 4x, and b square is x square, so minus x cube plus minus 2ab term 4x into minus x, so plus 4x square dx. So these two gets cancelled. So this is equal to 2 into x from 0 to 2. Now 2x cube minus x cube, which is x cube minus 4x square plus 4x dx. So by integrating this, we get this is equal to 2 into integral x cube. So x power 4 by 4 minus 4x square, 4x cube by 3 plus 4x, x square by 2 from 0 to 2. So upper limit 16 by 4, so 2 power 4, 16 by 4 minus 4 by 3 into 8 plus 2 into 4. So which is 4 minus 32 by 3 plus 8. 12 minus 32 by 3, which is 36 minus 32 by 3. So 8 by 3. Similarly, we need to evaluate the volume integral of del cross f bar dv, which is the triple integral of del cross f bar is a vector, the j bar minus 2y k bar, j bar minus 2y k bar, so dz dy dx, which is equal to, here again the limits x from 0 to 2, y from 0 to 2 minus x, and z from 0 to 4 minus 2x minus 2y. The first one is j bar into dz dy dx minus 2k bar into again y dz dy dx. So we need to integrate with respect to x, y and z one by one. Z from 0 to 4 minus 2x minus 2y. So here it is very simple that there is no function, it's a constant function 1 into. So first integrate with respect to z, you will get integral dz, which is z between the limits, and then with respect to y, and then with respect to x. So if you want, you can evaluate these two separately, or else here itself you can evaluate one by one. So j bar into x from 0 to 2, y from 0 to 2 minus x, this is z from 0 to 4 minus 2x minus 2y dy dx. Similarly here minus 2k bar into x from 0 to 2, y from 0 to 2 minus x, and integral dz is z. So 0, since y is constant, here we treat y as constant. So that's the main point. And now applying the limits, x from 0 to 2, y from 0 to 2 minus x, 4 minus 2x minus 2y. Now with respect to y, k bar into 0 to 2, y from 0 to 2 minus x, here we have y. So y into 4 minus 2x minus 2y dy dx. So after simplifying, we get volume integral of del cross f bar dv is 8 by 3 j bar minus k bar. So in today's session, I have solved one more problem on volume integration. So evaluation of volume integration includes the evaluation of triple integral, and we find the limits of three variables x, y, z, and if it is required to find the volume integral of f bar, just integrate its components, or else if it is required to find volume integral of any value, div f bar or curl f bar, then first find these two values and apply the same procedure. So that gives the required volume integration. So this is for today's session, and we will meet in the next session.